Welcome back, everyone. In the previous video, we created our report builder, which is responsible for handling the logic for generating a report. It fetches data from the Legend of Zelda API, converts it to a CSV, and uploads that to our S3 bucket. In this video, we're going to be implementing our reports-related endpoints. We're going to have two endpoints to implement. We're going to have the post endpoint and the get endpoint. The post endpoint is going to, of course, create our report and publish an SQS message into the SQS queue. And then we're going to have the get endpoint with the report ID as a path parameter, which allows us to retrieve the report state from the database here. And we're going to have one more behavior on the get endpoint, and that's going to be generating our pre-signed download URL if the report is in the completed state. So assuming that it was successfully uploaded to this S3 bucket, we can then generate a pre-signed URL with an expiration, and then the client can use that URL to actually download the report on the client side. So to get started, we're going to go ahead and create a handler on our API server. And of course, we're going to wrap it in this handler. And the payload for this endpoint is actually going to be a JSON payload that contains a single field, which is the report type that we're going to be building. And I mentioned this previously, but we don't really use the report type in our report building logic. But if we wanted to make the report generation more complex, we could add different report types to make it a little bit more interesting. And of course, since we're having a payload here, we need to add a validate method so that we can decode this request payload. Okay, so now we should be in good shape to decode this request. And we need to make this not a pointer receiver. Okay, so at this point, we have the report type that we want to create. So now we can create a new database record for this report. And we do not have this table store in our generic store object, so we're going to go ahead and add that. We'll provide the context, and then we need to provide the user ID and the report type. So if you'll remember, in our middleware that we created, the auth middleware will actually validate the JSON web token, extract the subject, which is our user ID, the principal making the request, and we actually use that to retrieve the user from our database, and we store that in our context. So we now have a mechanism for extracting the user from the context. We just don't have that helper implemented yet. So let's go ahead and add that. We can say user from context will provide a context, which will be the request context. And we'll expect to retrieve a user and a bool if it exists. So we can say if not okay, or user is equal to nil, we'll return false. Otherwise, we can return the user and say true. So now I can say the user is equal to user from context, and we provide the request context. If for some reason this is not okay, we will just say status unauthorized, but I expect this to not ever happen since this endpoint will be protected by our auth middleware. So we should always have the user. So let's go ahead and provide our user ID, and let's provide our report type. So now that I've created a report record in our database, I want to submit an SQS message so that our worker can pick up this report for asynchronous processing. So what is our SQS message going to look like? It's actually going to be the composite key that makes up the database record. So it's actually going to be the user ID and the report ID. What I want to do is actually send this message as a JSON object. So I'm going to create a separate type for that under our reports package so that we can reuse this. So I'm just going to create an SQS file, and I'm going to create a SQS message type. It's going to take the user ID and the report ID. So now over in our handler, we can go ahead and construct this SQS message and prepare to publish that using the SQS client, which we'll provide as a dependency to our API server. Before we go ahead and prepare the SQS message, let's go ahead and add the SQS client as a dependency. Now we can prepare our SQS message. So it'll be the report.userid and the report ID itself. So now let's use our SQS client and we'll send a message. We'll provide in the context, and then we need to provide a certain input param. And what we're going to need to provide here is the message body and the queue URL. What we currently have is the queue name, and using that information, we can get the queue URL. So what we're going to do is go ahead and get the queue URL, also using the SQS client. Get queue URL input will provide a queue name, and we have reference to the queue name in our config. So we'll just say s.config.sqsq, expecting a pointer to a string. So we need to wrap this in AWS string, which is simply a alias for string pointer. The actual return type here is, let's say, queue URL output. Let's check the error. And from here, we can say queue URL is equal to queue URL output.queue URL. And then we'll say message body is equal to a string pointer. So we need to convert this to JSON. So let's say JSON dot, and we'll provide SQS message. We'll say bytes. Okay, we can say AWS string, and then we'll say string bytes. And that is our message body. So on the receiving end, whenever our worker picks up an SQS message, it can unmarshal the JSON back into this type here. We can reference the user ID and report ID. So let's get the send message output. Let's handle the error. I don't think there's anything from this output that we need. There's the message ID. This is all just sort of metadata about the message that was published. So what I'm going to do is reference it that way. And the last thing I want to do here is return the report in the response. So I actually want to create a new report type struct that represents our user-facing report structure. It's going to look very similar to the database record, but we'll have some slight modifications. And I think we're going to have a reference to almost all of these. So I'm going to modify these and just write JSON. Actually, I can do this. What we want to do is omit empty on these as well. So let's say omit empty. What I can do is do this. And I want to add one extra field here, which is the status. And it will be a string. And I want to actually derive the status from these timestamps. So what I'm going to do, I'm going to actually add a status method here. So what I actually want to do here is if the started at timestamp is nil, the worker has not picked up the report yet and started processing it. So I'm going to say that this is in a requested state. The worker has not started yet. So let's go ahead and do a switch case. And let's say r.startedAt is equal to nil. Then we'll say started. If started at is not equal to nil, and let's say the report is not in a done state. So if we're in a not done state, if completed at is nil, or failed at is nil. So let's go ahead and add a helper for that. Either one of these is populated, that means we're done. So I'll say if we're not, our dot is done. In this case, we'll say we are processing. And then if we have completed at populated, then we'll return completed. If failed at is not nil, we'll return failed. Otherwise, we'll just say unknown. Now when we map the database struct to the public API struct, we can use this helper to determine the status. So let's go ahead and return this as the response payload. And to avoid collisions here, I'm just going to call this API report. So now at the bottom here, we can use our encode helper to return this as an API response. So we'll say if error encode, we can say API response, and it'll be an API report. Data will be a pointer to an API report. Let's go ahead and pass our status, which is status created. And then we can say the writer, go ahead and handle the error. Now we can just map each of these fields back into this API report type. So we'll say ID is report ID, report type. Okay, so now we've got the database report type mapped to the API report type. This looks pretty good. I'm just going to return nil here at the bottom to satisfy the error return type. We should be in good shape to try this out. Need to make sure that we're providing the SQS constructor to the server. So I'm going to go back into this test helper we had and copy the constructor. All right, so the API server is now running. I'm going to go ahead and sign in using the previous user and password. So now we've got a access token that we can use. And the data that we're going to publish here is a JSON payload containing the report type. All right, cool. So we got a page 404 not found. That's of course because I forgot to register the handler like I always do. Cool, so let's restart the server. Internal server error. Specified queue does not exist. Cool. So I'm going to restart, and I'm going to make sure that Terraform is applied. All right, now that that's completed, let's go back and try this again. I'm just going to do the same command. And we've got our report back. We've got the ID, the report type is monsters, created at, and the status is started. I would expect it to be, if started at is not equal to nil. Okay. Okay, so now what I want to do is actually create another endpoint where I can retrieve the status of a created report and continuously pull for that status. Okay, so let's create another handler to retrieve the report by ID. So we're going to expect a path parameter of report ID. And we'll just make sure that we can parse it. And our status here will be a bad request. Now what we can do is use this ID to retrieve the report, but we need to have a reference to the user ID as well. So let's go ahead and grab the user. If we don't have the user, we can just say unauthorized, even though we're expecting this scenario to never happen on this type of endpoint. Okay, so we can say s store s.store report store by primary key. Now we can use the user ID and the report ID. And one thing I'm going to check here is if the report does not exist, I'm going to return not found. Otherwise, we can do a internal server error. So we'll say errors.is SQL no rows. We can return status not found. Otherwise, we'll return internal server error. For now, I'm going to go ahead and just return this report object in the response. And I'm actually going to copy whatever we have up here, except I am not going to return status created. It'll just be status OK. And then finally, we can return nil as the error value. OK, so let's go ahead and restart the server. One thing, I forgot to register the handler again, so let's go ahead and do that. I'll never not make that mistake. This will be a get to reports, and this will be the report. Actually, we can just use ID here. I kind of like that better. So in the handler, let me make one more change. We'll just call this ID, since we're already on the reports endpoint. Okay, so let's restart the server. And I've already got this existing report in the database. So I'm going to do the same request here, except we're going to make it a get. We'll have reports, and then we'll have this UUID. I'm going to pipe this into JQ so we can see the JSON a little bit better. All right, I've created a brand new report here. The status is obviously incorrect, so we need to go back and fix that. But let's do this. Page not found. Ah, silly me. We need to wrap IDs like this. So let's go back here, restart the server. This is what happens when you're a little too trusting with your IntelliSense. So pipe it into JQ. I can see that we've got our report now. Now I need to fix the status. I don't know why this keeps saying unknown. Let's go back and fix that. Started at is not equal to nil. I meant to say if started at is equal to nil, this should be requested. Okay. So started at is equal to nil, it's requested. If started at is not equal to nil and it's not completed, processing. And then for these scenarios, completed and failed respectively. So restart, requested, perfect. So this looks great. There's one more thing we want to do in the get report handler, and that's generate our pre-signed URL with an expiration if the report is in a completed state. So what we're going to have to do here is add some branching logic. If report completed at not equal to nil. Now I want to do a couple of things in here. I first want to check. So there's a couple of things we need to do here. We need to make sure that we have access to a specific S3 client, a pre-signed client. It's not just the S3 client. There's a specific client that we have to use to generate pre-signed URLs. We need to determine an expiration for the pre-signed URL. So I'm going to do something pretty short, like 10 seconds. Okay, so now what we need to do is construct our pre-signed URL client. So I'm going to go to the API server and add pre-signed client here. It's going to be s3.presign client. Okay. I'm going to go back to this AWS test here and copy the S3 client and use that in the API server. And then what I'm going to do is create a pre-sign client from that. and it's just going to take in the S3 client. Okay. So now using the pre-signed client, I'm going to generate a pre-signed URL using the object that's stored in S3. So let's say signed URL error is equal to pre-sign client pre-sign get object. We'll use the context, and then we'll say we have to use get object input. Okay. Get object input takes in the bucket and the key. The bucket is located on our config here, and then the key is going to be located on the report object. Oops, this is already a pointer, so we can just provide this value directly. Handle our error. And one thing we need to do here is when we invoke this pre-signed get object, we can pass in an option. And the option here will be the expiration. Actually, this is going to be a duration directly, so we can just say times second times 10. That's good. And we are still going to use this value because we also want to persist this information in the database. So now what we can do is update our report. Download URL expires at. We can pass expires at. And now we can say report, s.report store update, handle the error here, and return the error. And there's one additional improvement I want to make to this. Ideally, if there were many requests being made per second to this endpoint, I wouldn't want to regenerate the pre-signed URL every time. So what I should do is say if the URL is expired, then regenerate it. So if completed at is not equal to nil and report.download URL expires at is not equal to nil and download URL expires at is before time.now, then we can do all this stuff. So it's a little bit of a long expression there, but that's fine. So I think this is good. Whenever I try to retrieve this again, the report will still be in a requested state, so none of this will actually execute. We're going to have to actually implement our worker and have it process our report using the report builder in order to get this to execute. So let's go ahead and test this real quick. And I'm just going to make the same GET request to that ID. Issue, token is expired, so didn't parse. Let's re-sign in and do the same thing. Okay, so it has returned our report, which is in the requested state. Okay, great. So now we've implemented both of our reports endpoints. We've created the post endpoint, which creates our report, stores it in the database, and publishes the SQS message. And we've implemented our get endpoint, which retrieves the report from the database and generates the pre-signed URL if it's in a completed state. Next, what we need to do is implement our asynchronous report logic. So we're going to have to implement the SQS worker that actually invokes our report builder using the information provided in the SQS message. So we're going to work on that next.